Hey, so today we're going to be doing this question and it asks us to balance the chemical equation. So first of all, we want to add variables in front of each part. So I'll just do x, y, z, and s. And then, so now what we want to do is go by element and then set the left and right side equal because it needs to be balanced. So for example, for aluminum, we have x because there's only one aluminum over here. And then we have an equal sign. And then over here, as we can see, we have 2 aluminum. So that'll be 2Z. So then for iron, that'll be Y, 1Y, equals 1S because they're already equal. And then next for oxygen, we'll have Y because there's only 1. And then on the right side, we can see we have 3. So that'll be 3Z. So now we can rewrite this as x minus 2z equals 0, y minus s equals 0, and y minus 3z equals 0. And then with this system, we can put it into a matrix. So we have 1, 0, negative 2, 0, 0, 1, 0, negative 1, 0, 1, negative 3, 0. And then they're all set equal to 0. That column won't change. It won't be affected when we do any row operations. So first of all, I'm going to try to put this in reduced row echelon form. So first I'm going to do row 3 minus row 2. So the first 2 rows will stay the same. And then the last row will become 0, 0, negative 3, 1. And then this is the same. And then I'm going to do row 3 divided by negative 3. And so we'll get the same 2 first rows again. And then we'll get 1 and negative 1/3. So as we can see, we have a pivot in all of the columns for x, y, z, but not for s. So s right here will be a free variable. So basically what that means is that we could set s equal to anything, and that'll just affect what the other variables are. Okay, so now what we can do is put these back into their equations, and because s is a free variable, anything that would have been s, we can set equal to t. So for example, our first equation, we have x minus 2z equals 0. Our second equation, we have y minus, and this would be s, but we can change it to t now, equals 0. And then we have z minus 1/3 would have been s, now can be t, equals 0. And then so next, I'm just going to move the t's to the other side. So starting from this bottom one here and going up, we have z equals 1/3 t, y equals t, and we have x equals 2z, which can also be rewritten as x equals 2/3 t, because we know what z is, and we want them all in terms of t. So now what we can do is put them all in a column vector. So we have x, y, z, and s, and so x equals 2/3 t, y equals t, z equals 1/3 t, and s equals t. And then so what we want to do is get all whole numbers, because when you balance this out, you don't want to have like half of aluminum. Like, that doesn't really make sense. So what we can do is pull out 1/3 t, and then what will end up is 2 x's, 3 y's, 1 z, and 3 s's. So now this is our answer, but we can rewrite that now. So we have 2, 3, and then 1, and then 3. So now this is our answer, and it is solved.